Hello my friends, welcome to this new practical activity on this time the naive Bayes classification model. This is our fifth classification model we're implementing in this part 3 classification. We already implemented logistic regression, k-nearest neighbors, SVM and kernel SVM, and so far the best accuracy we've got with these four models is 0.93, 93%, which we got with both k-nearest neighbors and kernel SVM. And now we're about to implement a new classification model, the naive Bayes one, a very well-known and widely used, so you definitely want to have it in a toolkit. And so the big question is, will we beat that best accuracy of 0.93? Alright, so let's start immediately because I can't wait to show this to you. But just before we start, let's make sure everyone here is on the same page. I gave you the link to this folder right before this tutorial in the article, so make sure to connect to it. And now let's do this. Let's start the implementation of naive Bayes. So we're going to go into this folder and we're going to start with Python as usual. And inside this folder, you will find two files, the naive Bayes implementation in the IPYNB format and the same social network ads dataset, which I will quickly re-explain. So this is a dataset containing 400 customers. Each row here represents the customer. And for each customer, we get the two features, age and estimated salary, with which we are going to predict the dependent variable purchased, which tells if yes or no, the customer bought the SUV. So 0 means that indeed the customer didn't buy the SUV, and 1 means that the customer bought the SUV. Alright, so we're going to train a new classification model to understand the correlations between these two features, age and salary, and that dependent variable purchased in order to predict the customers that will buy the SUV. And once we get these predictions, we will target these customers on social networks with some beautiful ads of this beautiful car. Alright, so that's the same story, and now we're going to start our implementation either with Google Collaboratory or Jupyter Notebook. Feel free to choose your favorite, and I can't wait to see if we're going to beat the accuracy, and I can't wait also to show you the visualization results at the end. Alright, so right now it is loading and laying out the notebook, and here it is. Here is a naive Bayes implementation, still resulting from the same classification template which we made in the first section of this part 3 when implementing logistic regression. So basically all the cells here are the same as in this logistic regression implementation or classification template. The only cell that will change will be, the one where we build and train the classification model, meaning this one. That's the only cell that we will re-implement ourselves because all the rest is the same. But this notebook is in read-only mode, and therefore in order to re-implement that cell, we need to create a copy of this notebook by clicking Save a Copy in Drive. And as you can see, this will create a copy in which we will be able to re-implement that cell. Alright, so once again laying out the notebook, and there we go. Here is our copy on which we are authorized to modify anything, and especially that cell we want to re-implement. So I'm scrolling down here to find it. Here it is, training the naive Bayes model on the training set. So let's immediately remove that cell because I want you to re-implement it from scratch as if we had no idea on how to implement this. Alright, let's create a new code cell, and now your turn. I want you to train your machine learning independence by figuring out by yourself how to indeed build and train that naive Bayes model on the training set. So of course, to do this you have several options. You can directly type in the search bar of Google or Bing, naive Bayes scikit-learn class. Okay, or you can navigate the scikit-learn API, which is right here, in order to find that class which we need to build our naive Bayes model. And my personal recommendation is to try with the second option because indeed this will get you familiar with this API, and the more you get familiar with it, the better. Okay, so please press pause now, try to find this class and then try to build this naive Bayes model and train it on the training set. And now in 2 seconds, we will implement the solution together. All right, let's do this. Let's build this naive Bayes model with scikit-learn. So the API is huge and this is organized in alphabetical order. And so the first thing we'll try is to find, a module called maybe naive Bayes, right? Just the name of the model. So we will scroll down to N, the letter N, and we'll see if we get naive Bayes somewhere or something close to it. Let's see, linear model, manifold learning, metrics, we're getting close, and Gaussian mixture models, model selection, multi-class. Wow, there is a lot of M. Okay, perfect, naive Bayes. So let's click this, naive Bayes. All right, and so the module indeed is naive underscore Bayes. And among these models, well, according to you, which one are we going to take here? That's a good question, actually. Well, in fact, the classic one and the one that you learned in the intuition lecture is, of course, this one, the Gaussian naive Bayes, Gaussian NB. And that's exactly what we'll use to implement our naive Bayes model. All right, so the name of the class is Gaussian NB, and this time the good news is that we won't have to worry too much about the parameters because there are actually only two parameters. Priors, which are the prior probabilities of the classes, if specified the priors are not adjusted according to the data. So, of course, for this we will keep the default value of none, right? We won't specify some priors here. And for the second one, var smoothing, it is the portion of the largest variance of all features that is added to variances for calculation stability. The default value is 1 times 10 to the power of minus 9. We will just keep that default value, that's fine. You know, we will worry later about parameter tuning, which indeed allows you to tune the values of your parameters, but that will be covered in part 10. And so here, very simply, we will just call this class without inputting any parameters. So that's super easy. Let's copy this and let's go back to our implementation, the copy one. Let's paste that here. Let's remove this little thing here. And now you know how to adapt this. We need to start with from, the naive Bayes module of the scikit-learn library. And then here you add import. There we go, that Gaussian NB class. Perfect. The next step is to, of course, create an instance of this class, which will be an object representing exactly that naive Bayes model. And so there we go. We're going to call this, as usual, classifier in order to be coherent with the next sections of this implementation, and mostly so that we don't have to change anything, right? Because then we call this classifier variable to predict the results and visualize the results. So there we go, classifier here, and then equals, and then we're going to call this Gaussian NB class in order to create indeed this naive Bayes model. Okay, perfect. And now you know how to finish this. We need to take our classifier again, from which we're going to call the fit method, which will train this classifier on the training set composed of indeed X train and Y train, right? I hope you did it even faster than me, because indeed this is exactly the same as before. And now you are also independent and know how to find the information you need in the API. Okay, great. So once again, there we go. That implementation is over and we're ready to get the final results, and mostly we're ready to find out if we can beat the record accuracy, of 93%. So I can't wait to see, so let's do it right now. Let's click this folder button to upload the dataset, right? We have to do it in order to train indeed that naive Bayes model on the training set. So right now, your notebook is connecting to a runtime to enable file browsing. And once again, in a second, we should get the upload button. There we go. So we're gonna click it. And here we are in the kernel SVM folder. So let me show you the path once again. Please find your whole machine learning A to Z folder, which you could download in the previous tutorial if not already. And then inside we're going to go to part 3 classification, then section 18, we're making good progress here, naive Bayes, then Python, and then social network ads.csv. Okay, we press OK here, we have the dataset, all good, and now we can run everything in order to get indeed our new results. So let's do this, run all, and now all the cells are running, and especially this one, there we go. We now have our Gaussian naive Bayes model, and well, let's see the results one by one, starting with this one. So that's the prediction of a single result, that first customer of the test set of age 30 and estimated salary $87,000. And remember in the white test, the real outcome was 0, meaning that this customer didn't buy the SUV, and that's the prediction, which is indeed the correct prediction. And then when predicting the tested results, well, once again, we see that we have a lot of correct predictions. All this is correct, all this is correct. This is our first incorrect prediction, another one here, and then another one here. all correct, all correct. Another one here. Oh, I'm not sure we're going to beat actually that accuracy. We seem to have more than 7 incorrect predictions at first sight. Not sure, but let's see. Well, that's exactly what we're about to find out right now. So are you ready? The question is, will we beat the accuracy of 93%, which was the best accuracy resulting from both KNN and kernel SVM? And so let's see what we get with naive Bayes. And no, unfortunately, we don't beat the record. Indeed, the accuracy we get with that naive Bayes model is 90%, which beats, indeed, logistic regression, but does equally the same as the classic SVM model with a linear kernel. Alright, but still I think we will get nice visualization results. So that's the code cell where we visualize the training set results, and well, this time we got the results pretty fast. You can see that the cell is already executed. So let's see. I can show you that indeed the naive Bayes curve is pretty nice, right? It is a nice smooth curve, right? That catches well indeed these green customers here, the ones who in reality bought the SUV in the right green region. But unfortunately, it separated the two classes, with these two prediction regions a bit large, not very precisely. And that's why we don't get an accuracy that is higher than 93%. But still, we made a progress with respect to logistic regression, because indeed remember that for logistic regression, these green customers here could not be well classified, right? Because of this straight line, they fall in the red region. And here in our naive Bayes implementation, well, these green customers fall in the right region. So at least it corrected that. But since here there is kind of a large margin, well, these green customers which were correctly classified with the kernel SVM, if you remember, right? These are the training set results, right? So I'm talking about these ones. Here they are correctly classified, except these two and the third one, but clearly with naive Bayes, well, they fall into the wrong region. Okay, but anyway, at least you see the prediction curve of the naive Bayes model, and mostly you see that the naive Bayes model is clearly a nonlinear classifier. And in some other situations, because the naive Bayes is causing less overfitting, well, in some situations it will do better than your other models. So that's why it's always very important to try all of them. And remember, at the end of this part, I will actually deploy all our models with new simplified code templates for each model, without all the prints and everything, in order to deploy them in a flashlight so that we can quickly figure out what is the best classification model for any dataset, regardless of the number of features. All right, so that's for the training set. And now let's comment quickly on the test set. All right, this is already executed. Perfect. So here are the results of naive Bayes on the test set. And actually, we realized that here we were pretty unlucky. Naive Bayes was pretty unlucky because the 3 predictions that it missed, this red customer that falls incorrectly in the green region and these 2 green customers that fall incorrectly in the red region, well, naive Bayes was pretty unlucky on this one because, they're almost on the prediction boundary, and it is what it missed by very closely to beat the record. And same for this one, actually, This one was very shortly missed, right? Because it is an incorrect prediction of a customer who in reality didn't buy the SUV because it's red, but was predicted to buy the SUV because it falls in the green region. So pretty unlucky, which explains the accuracy of 90%. I think that if we tune a bit naive Bayes, we could beat the record, but once again, that will be in part 10. And now the next step will be to buy the last 2 classification models which belong to a branch of machine learning called ensemble models. I'm talking, of course, about decision tree classification and random forest classification. And actually, with these 2, and especially random forest, we might have a chance to beat that record accuracy. We might beat 93%. So that's what on the menu for this end of part 3. So I can't wait to see you in the next part to build first the decision tree classification model and then finally the random forest classification. And until then, enjoy machine learning.